Anatomy of the third quarter moon. Let's dive right into this explainer and demystify one of the absolute most fascinating phases of our entire lunar cycle, the third quarter moon. We look up at the night sky all the time, right? But how often do we really stop to think about the mechanical ballet happening right above our heads? Today, we're going to unpack the science, the geometry, and some really surprising trivia behind this specific phase. Picture this: you're rushing out the door, coffee in hand, maybe waiting at a long stoplight during your morning commute. You casually glance up and you see this pale, ghostly moon just lingering high up in the blue daytime sky. It almost feels out of place, doesn't it? Kind of like it forgot to set. Well, that everyday observation is the perfect way to ground our cosmic journey today, because you are very likely looking at a third quarter moon. Section 1. Anatomy of the third quarter. Right off the bat, let's clear up a really common point of confusion. You'll often hear this phase referred to as the last quarter moon. So if you're ever looking at an astronomy chart or a lunar calendar, just know that third quarter and last quarter are completely interchangeable. They literally mean the exact same thing, so don't let the different terms trip you up. Regardless of what you want to call it, to our eyes down here on Earth, the moon looks like a perfect half circle. Exactly 50% of the visible disk is lit up by the sun, while the other 50% sits in total shadow. It creates this incredibly striking visual balance suspended right there in the sky. But check out the stark contrast here. If you happen to be standing in the Northern Hemisphere, the third quarter moon lights up the left half of the lunar disk, and that is the exact opposite of the first quarter moon, which lights up the right half. Actually, it's a super handy trick for amateur astronomers. If the light is on the left, you know for sure you're looking at the latter half of the lunar cycle. Section 2. The orbital geometry. To really get why we see the shadow, we kind of have to trace the timeline of the whole lunar cycle. We start at the completely dark new moon. From there, if we wind the cosmic clock forward about 3 weeks, boom. That 3-week mark is exactly when we arrive at this beautiful half-lit phase. And honestly, the name third quarter makes total sense when you map out that journey. At this 3-week point, the moon has completed exactly 75%, or 3/4, of its orbit around Earth relative to the sun. It just has one final 25% stretch to go before it returns to a new moon and the whole shebang restarts. So the absolute most crucial point in all this is the angle. We're talking exactly 90 degrees. At the precise moment of the third quarter phase, the moon is locked in a strict 90-degree geometry to both the Earth and the sun. You, standing right here on Earth, are sitting at the corner of a giant cosmic right angle. Now, this builds directly on what we already know. It's actually the exact same 90-degree angle that gives us the first quarter phase earlier in the month. But here's the kicker. The moon is now sitting on the complete opposite side of this orbital path. Same exact angle, but opposite side of the track. And that is exactly why the sunlight hits the opposite hemisphere of the moon from our perspective. Section 3. The morning moon. Let's bring this grand orbital geometry back down to your backyard. Knowing where it is in space gives us a very specific timetable for when we can spot it. It breaches the eastern horizon right around midnight. Then it travels across the dark sky, reaching its highest, most prominent point in the sky right exactly at sunrise. Finally, it gently sets in the west around noon. Because of this unique schedule, the third quarter is absolutely the ultimate morning moon for early risers. This is exactly why you see it on your way to work or school. Since it peaks at sunrise and doesn't set until noon, it literally spends the entire first half of your day sharing the sky with the sun. Section 4. Shadows on the Terminator. If you ever get the chance to look at a half moon through a decent telescope, you're going to want to focus your gaze right on the terminator line. That is the stark dividing line separating the illuminated daytime side of the moon from the pitch black nighttime side. believe me, that's where the magic happens. Right along that terminator line, the sun is essentially rising or setting from the perspective of the lunar surface itself. And that super low angle, it casts incredibly long, dramatic shadows. We're talking shadows that perfectly highlight deep craters, jagged mountain peaks, and vast ridges. Plus, because the illumination angle is completely opposite to the first quarter, the terminator sweeps across entirely different terrain, revealing craters that were totally washed out in harsh light just a few weeks prior. It's like looking at a whole new landscape. Okay, I want to share a really fantastic, unexpected trivia nugget straight from our source material. This is going to challenge what we thought we knew about this supposedly perfect half moon. Take a look at this quote. We always say the third quarter is exactly 50% illuminated, but due to a quirky little bit of cosmic geometry and the elliptical shape of the moon's orbit, true 50% illumination actually happens a few minutes after the official astronomical moment of the third quarter phase. And amazingly, this is the exact opposite of what happens at the first quarter, where true half illumination hits a few minutes early. It just proves that our solar system is incredibly dynamic and absolutely nothing is perfectly static. It really makes you appreciate the staggering mechanical precision required for the universe to function, doesn't it? So if the third quarter isn't exactly half lit at its official moment, when are you going to look up at the morning sky to try and catch that perfect fleeting balance? Keep your eyes peeled on your next morning commute. Thanks for joining me on this explainer, and as always, keep looking up.